Alright, hey guys, Rs Motorsport. Today we're with the IE intake for the TTRS and Rs3. Just wanted to kind of explain the intake and why we are using it on a lot of our projects and builds. So the story with the IE intake is that with the Mark 7 Golf R and S3, IE made some intakes, but they made them independent of what we were doing, and on some of the really big MQB, MK7R kits. Yeah, so with the Mark 7 Golf R, we started making a bunch of power with those intakes of IE and 034. A lot of those really nice intakes on the market, they just didn't flow enough for our kits. And so when the Rs3 was announced to the States, Pete over at Integrated Engineering, he contacted us and just said, hey, we want to build a really nice intake for this platform. What are your needs? What are your desires? And so I had a big checklist. The things that were really important to me. I wanted it to be a sealed box so that at speed we could have some sort of positive pressure inside the box. I wanted it to be a massive filter. It needed to be able to flow at least enough air for our 1,000 horsepower kits. It needed to have a really big frontal area so that we could get as much clean air off the front of the engine. And then another really important thing for us is we wanted it to have a massive velocity stack on the inside and one that faced forward so that we could get a little bit more of a ram air effect of track if we remove the filter. Another big feature is that all of our intakes are 4-inch for our big turbo kits, so we wanted something really big that was going to be able to support those kind of power levels, and while still being able to work for the stock intake, we also wanted to make sure that it handled our 1,000 horsepower kits. So the intake was really designed around our big turbo kits for both the 850 and 1,000 horsepower. They work phenomenal for stock turbo as well. Yeah, come on around, Alec. Let me show you kind of the problem with the stock intake system. Yeah, so basically what you have going on here is that on the bottom of this chart, it shows on this green line, it'll show your OEM vacuum post element. So this is just sampling inside the tube, the black tube that goes over the turbocharger. It's sampling the amount of pressure in that tube. And what you can see is in the beginning, off idle, it's very negligible vacuum. So we're at 91, 92 kPa here in Las Vegas, so that would be 91, 92 kPa on the onset. But as RPM increases and there becomes more and more airflow combined with more and more boost, you see fun little spots like when the variable lift kicks over, it dumps a bunch more vacuum into the tube. And by the time you get all the way here up to red line, you're at 0.8 of a PSI, roughly 7, 8 kPa. And that's important because on a turbocharged car, you work in pressure ratios with how much your base pressure is times a pressure ratio. So this turbocharger, this compressor is very similar to an EFR 6758, which at redline is working at about 1.3 bar in a pressure ratio situation. So if you're only starting off with say 85 kPa or 85% of an atmosphere, your max boost is going to be 1.5 times that, and that's why you see big gains, very typical gains like what we saw on the first car we ever put on, which was Tim Meyer's car, and we've seen it on a bunch of stock turbo cars just the same. Let's wait for this old computer to load. Where as you go further and further up the RPM range, the gains get bigger and bigger and bigger, and it's mostly because here in the mid-range, we're not running 100% of the turbo, so any difference in vacuum for the turbo is being compensated by just maybe a little bit more N75 value, a little more turbocharger being used. Once you get up into the 5,500 RPM range, the turbo is pretty much going wide open. There's no more turbo to have, so the only way you're going to end up making more power is less restriction, having a more favorable pressure at the turbocharger inlet. So you see the gains up top. When I see a graph for an intake and there's just gains everywhere, that's a huge red flag for me that it's doctored data, because the OEM filter does a pretty dang good job for the amount of horsepower it was designed to push. It's just up top that you typically
get the gains. And that's good because that right there is your area under the curve for, you know, what propels the car down the quarter mile. You know, that's your power under the curve. So that kind of explains the data portion of why the intakes actually make power. We don't see a ton of gain, if any, on the stock calibration. We only really see them on stage 1 and stage 2 stuff.